To create an animation, we draw a series of frames. The thing that lets us know how one frame differs from another is a variable that processing maintains for us, called frameCount. Remember that animation is really just showing one picture after another very quickly. Processing tries to draw a new picture for us 60 times a second, and when you show a new picture to someone 60 times a second, their visual system will fuse the images and make it look like smooth animation. The key to doing this in processing is the variable frameCount, written in this typical processing way, one word, lowercase f, capital C in the middle. FrameCount is an integer, and it just tells you which frame number you're at. When you're drawing the first frame, FrameCount has a value of 1. The second frame, FrameCount is 2, and so on forever. To see how processing manages animation, let's look at an analogy. Suppose that you're on a rowing team. The first thing every morning, you get the boat out, you put the boat in the water, you climb in. That's the setup. Then you race, and there's someone in the back telling you, stroke, stroke, stroke. Each time they call out stroke, you pull the paddle. This is how processing does it. We have a setup phase, and then one thing gets repeated over and over and over. To create a little animation, first we set up everything, we create a graphics window, and then processing calls draw, and we draw a picture. When we're done, everything stops, and processing takes a little vacation. Your computer goes off, it checks the mail, it plays your MP3 player, until a 60th of a second has passed. And then processing says, oh my gosh, it's time for a new picture. Comes back to your program and says draw. And then processing takes a break. And when a 60th of a second has elapsed, it calls draw. And so on for every frame. And of course we can number these frames, and these numbers, 1, 2, 3, 4, 5, are the value of frameCount. In the past, we've drawn things by wrapping them in this little template, void setup and a pair of curly braces. Inside we make the graphics window and we draw the graphics, which we can think of as preparing our materials and then drawing the picture. This has worked fine if we want to draw just one picture, but for animation, we want to set up once and then draw over and over again. So I'm going to separate these two things. Off on the left-hand side, we still have void setup and the calls to make the window. On the right-hand side, we have now the drawing routine, and that gets wrapped up in a line called void space draw, open paren, close paren, with nothing between the parentheses, and an open curly brace, then all your graphics code, and a closing curly brace. That's the wrapper for all of your draw stuff. So when your program first begins, processing says, man, I hope you have something called setup. And it looks through your code and it finds setup. And it calls it. Almost always, this is where you will create your graphics window and call smooth. Then, processing calls draw automatically, and it executes all of the commands inside of draw. When draw is finished, processing says, okay, we're done for a while, and it goes off and it checks your email or something, and then a 60th of a second has gone by, and processing wakes back up and says, time for a new picture. It automatically calls draw. Draw creates a new picture, processing shows you, and then processing goes back on vacation. And your computer plays some music on your MP3 player until a 60th of a second has elapsed. Processing says, oh, I'm back, call draw, and in this way, it calls draw for you 60 times a second. Let's actually write a little bit of code to do this. I'll write a little routine to draw a rectangle. So here's our setup, size and smooth as always, background and rect. So this will draw a little rectangle for us. Now I want to change it so we can have some animation going on. So I'm going to create another routine, void draw, paren paren, open brace, curly brace. Right now it doesn't do anything. So let's move the drawing commands into draw. This now is the very same program. And in fact, if we run this, we'll see the very same thing. We'll just see a single rectangle sitting there because every frame is the same. Well, we'll change that in a second. To see how to do that, I'm going to move the setup stuff into a small type and put it up in the corner to remind us that it's necessary, but I don't want to focus on that right now. I want to focus on draw. So what is this thing going to draw? Well, a gray background with a rectangle inside of it. Let's focus on the left edge of the rectangle. That's given by this number 50. What I want to do is move the rectangle to the right over time. So I want to change this number 50 by somehow using frameCount, because that's the variable that changes over time. So okay, let's open things up a little bit, and instead of just drawing the rectangle at a left edge of 50, I'm going to draw it at 50 plus frameCount. Remember, we don't have to create frameCount, processing makes it for us. So let's see what this draws. On the first frame, frameCount has the value 1. So the left edge of the rectangle is at 50 plus frameCount, or 51. And you can see in the picture that in fact the rectangle is just a little bit to the right of 50. I'm exaggerating these distances so that they're easy to see. In reality, a rectangle that is 1 pixel to the right of 50 is going to look pretty close to 50. But as time goes on, it will move to the right. When frameCount is 2, now we have 50 plus frameCount is 2. So the left edge of the rectangle is at 52. The next frame count is 3, so the left edge will be at 53. And this goes on forever until you stop the program. After 10 frames, the left edge of the rectangle will be at 60. After 100 frames, that happens after the program has been running just a little bit over a second and a half. The left edge of the rectangle is at 150. At 200, the left edge is at 250, and so on. And eventually, in this simple little example, the rectangle will just slide off the right-hand edge of the screen, which for now is okay. We're just trying to make things move. Let's see this in action. Here's the same program we just saw. Let's run it. There we are, our unchanging rectangle. Now let's move it to the right. So I'll do just what we did in the slide, and now let's run this. And there goes the rectangle. Every frame count goes up a little bit, and the rectangle moves to the right. Suppose we want it to move faster. Well, I don't want to add just frame count. Maybe I'll add 2 times frame count. And I'm going to wrap this in parentheses because I want to make it really clear what's happening. I'm taking the value of frame count and doubling it and adding that to 50. How does that look? Well, that's much faster. Very nice. Well, we can do this to all 4 of the numbers that control the rectangle. So I'll put each one on its own line. That's just for convenience. And now let's change the top of the rectangle. So the top now will be at 75 plus the value of frame count divided by 5. So it's going to change much more slowly than the left position. If I run this, you can see the rectangle is drifting down very slowly. I'll change the width. So now the width is getting larger on every frame, and let's change the height. So now I'm taking the value of frame count, dividing it by 2, and subtracting it from 200, which is the height. So the rectangle is getting thinner as it moves. And of course, it eventually moves off the screen, but that's fine for now. Just for fun, let's change the color of the rectangle. So I'll make a fill statement, and let's make the red value frame count itself. The green value will start out very bright and get smaller over time, not too quickly. And let's say the blue is always 128. If I run this, the color is changing. Let's make it change a little bit faster. Remember that one of the nice things about fill is that if one of the color values goes below 0, it just treats it as 0. And if it goes over 255, it just treats that as 255. And there's a nice color change. So this is the essence of how to create animation. We have a setup routine that gets called once. We have a draw routine that gets called every single frame. And inside of draw, we can use the variable frame count to change things from one frame to the next.